Yes, the screen is visible to everyone. Okay, so we have a question here where there is a lens that forms an image of an object placed at a distance 45 centimeter from it on a screen placed at a distance 90 centimeter on the other side of it. There are two information readily available with us. So the question part is you have to state with what type of or what kind of lens it is. Is it convex or concave? And the B part of the question is you're supposed to find the focal length of the lens and the magnification of the image. Okay. So first of all, there is some lens we don't know whether it's a convex lens or whether it's a concave lens. But we know the object is placed at a distance 45 centimeter from it. So whatever lens it is, from the optical center, somewhere at 45 centimeter distance, there is an object kept. And the image is formed at a distance 90 centimeter on the other side. That is on the opposite side. So somewhere over here, placed, let's say 90 centimeter will be much far. 90 centimeter. Somewhere over here, the image is formed. So we have two information. One is the object distance. Always remember, object distance will always be taken negative. See, in your question, they are not going to state whether positive or negative. They will only give you the values. You have to smartly work here, considering should you take u value or v value positive or negative. But there is one good thing that every time you take lens question, u value is always going to be negative. So you will write, because if you do not mention these negative sign and when you put it in the formula, you're going to get some or the other incorrect values. So sign is very, very important when you do questions. So we have the u value as minus 45. And whenever you have any lens, it can be, as I said, convex lens or concave lens. If any image is formed, anything is formed on the right side to it, be it concave or convex, anything is formed on the right portion of the lens, then always that distance will be positive. Okay, so two things we get to know here. First is the u value is minus 45 centimeter and the value of v is positive. Why I'm taking positive? Because it's clearly written, it's on the other side, on the right side. So that is going to be positive 90 centimeter. Now these two values are very much sufficient for us to find the rest of the thing. So we will substitute that into the lens formula. Okay, so Rachel, tell me what is the lens formula? It's 1 by
Uh,
f.
1
Hmm.
by f is equals to 1 by
Hmm.
u minus 1 by v.
V minus 1 by u. Okay, 1 by v minus 1 by u. Okay, all right. So we just put up this because we need to find the value of f. So it's 1 by f. And here the value of v is 90, positive 90. It's minus, and be careful, the value of u is also negative. So put that negative sign with 45. Okay, now these two sign, negative and negative, this will become positive. I'll just come to the screen. Okay, work there. So it's 1 by f, 1 by f is 1 by v minus 1 by u. So it's 1 by 90 minus of 1 upon minus 45. So this will become plus 1 by 45. And then you work on the LCM part. I'll help you with the first solving, but be careful. This is something that you'll do in the other questions also. LCM is 90, so just multiply these with 2. So you're
Is
going
it
to
1
get how much?
1 by 30?
1 by 30, correct. So your answer is 3 by 90. That eventually becomes 1 by 30. But now this is the value of 1 upon f. We don't want to find 1 upon f. We want f. So you reciprocate f and you reciprocate on the right side also. So when you do the reciprocal of 1 by f, it will become f. And same thing you will apply on the right side. So 1 upon 30 will become 30, and that is 30 centimeter. Now this is positive 30. Okay, so first part is that you got the value of f, it is positive 30. Now the part is whether what kind of lens is that. A part was identifying the type of lens. So yes, done writing everyone. Yes, finish writing everybody. Now the type of lens, it's going to be a convex lens. Why we are predicting it's a convex lens? Yes, what's the reason why it's a convex lens? Yes, what is the reason it's a convex lens? Yes, Nisha. Why would you call this as a convex lens?
I'm not sure.
Okay, Adit, why would you call that as a convex lens? Because your focus is positive. Anytime we have done the power question also, remember, whenever your focal length is positive, your value is coming in positive, then it is always for convex lens. If your focal length comes out negative, this is the way to predict the kind of lens. They do ask you these questions, whether it's a convex or a concave lens. So what is the hint point? That the focal length is positive, then it is convex. If it is negative, it would be concave lens. Also, one more thing that gets to know is the image was formed on the other side of the lens. Correct? So this is, suppose this is, obviously we got to know that it is convex. Object was kept here at 45 centimeter and image was formed at 90 centimeter. Image was formed on the other side, on the right side. So these cases you will see in convex lens, and the image is formed exactly at a position given. They have not anywhere said that it is at infinity or it is somewhere beyond C or C1 or C2. They've exactly given you a position where the object is formed. That means at 90 centimeter, those two rays are actually intersecting. Correct? So that means it is giving us real image. And real image means it will be inverted. So this case only comes for convex lens. So two, three things are helpful to know whether it's a convex lens or a concave. First of all, the focus itself. Focal length, if it's positive, it's convex. Apart from that, the image is real, then it is going to be a convex lens, which is formed on the other part. Now we are supposed to find the linear magnification. So magnification, what is the formula? V upon U. V is the image distance, that is 90 centimeter. U is negative 45. So that's going to be negative half, which you can write as negative 0.5. That's the magnification. Now negative 0.5, if I may ask, sorry, it's not half, it's 2. Negative 2. So tell me whether the image is magnified, means is it enlarged or is it diminished?
It's diminished.
Yes, it is. No, it is enlarged. 2. Just look at the number. Forget the positive and negative side. Negative in this answer tells that the image is inverted and inverted images are real. This information comes from the negative sign. And the number part, the numerical value, which is 2, it is greater than 1. That means it's an enlarged image. Okay, so in some questions they can ask you not just the value of magnification, but they may ask you what's the nature of it, what is the nature, and also about the size of it. So that you will always pick up from the value. So always remember Magnification, whenever you read, let's say it's negative 0.5, just an example. So negative, you just have to know negative is given, that means it is an inverted image. And the inverted images are real images. And the second part is the number. If the number is less than 1, then it is diminished. And if it is greater than 1, it will be enlarged. Okay, so this question covered a lot of things. We could find the focal length, we could predict the type of lens, and also the magnification and the nature of image. Now let's take the next question. Yes. Now the question is, where should an object be placed in front of a convex lens which has a focal length of 0.12 meter to obtain a real image of size 3 times the size of the object on the screen? Okay, so what are they asking us? Read the question carefully. Okay, Michelle, answer. What are they technically asking us?
The object position.
Correct. Where should an object be placed means they are asking us the object distance. And it's clearly given, it's directly given the lens is convex. And the focal length is also given as 0.12 meter. You don't have to worry here, meter to be converted into centimeter. Not necessary in all case, but yes, you have to see if power based question was asked. For power, you need to have meter as the unit. If things were given in centimeter, they would have asked you power, then you have to convert centimeter into meter. But here there is no such need. So we have a convex lens, and the focal length of this lens is 0.12 positive. It's a convex lens, so this is also something you will have to mention from your own end. Though it is not given here, not mentioned whether positive, negative, but at least you have read it's a convex lens. So for that, the focal length will be taken positive 0.12 meter. And you need to have a real image size 3 times of the size of object. Some information is given to you. Now this part of information is related to magnification. Okay, so we have one thing which is focal length, which is positive 0.12 meter. U is what they're asking us. Now what about V? How, at least V is known, you could have directly found U. But if U is not known, V is not given, then how will you find the other terms? Because the formula, which is 1 by F is equal to 1 by V minus 1 by U, two of the information needs to be there. But if it is not there, then in such kind of question, they do give you magnification, some information about magnification. First part, how will you read the magnification value? It said real image. Now we know real images are always inverted. So that means the magnification value will be negative. That's the first part. Then they have said it is 3 times the size of the image. That means the value is negative 3. So this value was not directly given into your value. It was indirectly stated. So from this, you get to know the magnification value is minus 3. Okay, now how helpful is this? Magnification formula, we know it is V by U. Correct, I'll just do the screen. So magnification value is minus 3, and the formula for magnification is V by U. You know M is minus 3, V you do not know, and U also you don't know. Correct? These two information is not known to us. So what I will do is I'll shift the U to the left side. It will become minus 3U is equal to V. Now this is kind of a work that we will substitute. So wherever you have V, you will substitute that as minus 3U. Okay, so write this down. These extra work we'll have to do to get through our answer. If you've done right in this, then tell me. Yes, finish writing. Now we will use it in the formula, lens formula. It's 1 by f is 1 by v minus 1 by u. F value is known to us positive 0.12. V, instead of v, what are we going to write? Minus 3u. And this is minus 1 by u. Okay, so of course the LCM concept, for that I'll multiply this term by 3 to get the denominator same. That's going to be minus 3u minus of 3 upon 3u. So now the denominators are same. So what we will do, we'll just write it once. And that minus sign I'm giving on the numerator side. 1 minus 1 minus 3. So that's going to become minus 4. Okay, minus 4 upon 3u. And on the left side, you have 1 upon 0.12. Okay. Now, I'll just shift the 3u on the left side and this 0.12 on the right side. So it will get multiplied with 4. And now I will also shift the 3 to the denominator, just keeping u alone. So this way I will get the value of u. Calculate this part and tell me how much you're getting the value as u. It should be negative, and yes, every time if you're not getting the answer in negative, that means you did some mistake with the sign. U should come out as negative value. Yes, calculate this and tell me what is the value of u you're getting.
You get 0.053 minus 0.053 minus.
4, no? Well, you can tell, no, it should come out around 16, because if you check with 0.12, that is divisible by 3.
No, yeah, you get u is equal to minus 0.16 by 3, and I like divided that.
16 by 3. Okay.
Yeah,
No, but why 3? Because 3, see, when you divide it, it's already 0.4. Then you just have to multiply 4 and 0.4. So your final answer will be negative 0.16 meter. That's the value of u. So here you don't have to find the value of v, because in the question they've only asked you where is the object supposed to be placed. So you, once you get that u, then you can end up your answer and make sure you put that negative sign. And always you can add one more statement that the object is kept 0.16 meter in front of the lens. That's always a good ending statement you can write about the object distance. And anytime they ask you image distance, also you can state in the same way, in front of the mirror or behind the mirror. These terms are very important when you give the final statement. Yes, everyone got the same answer, 0.16 in negative. Okay, let's try the next question now. We have an illuminated object lies at a distance 1 meter from the screen. A convex lens is used to form the image of the object on a screen placed at a distance 75 centimeter from the lens. Now, if you clearly see, one information is meter, other one is centimeter. So make sure you get it in the same way. You're supposed to find the focal length and the magnification. Okay, so Adi, tell me what all information is available with us?
Uh, ma'am,
Hmm.
like we have M, right?
No, we have to find it.
Oh yeah, sorry. Uh,
Okay. Michelle, answer the same question. What all information we have from the question?
We have the object distance and image distance.
Okay, how much is it? Object distance is?
1.0 meter and the image is 75 centimeter.
Okay, so we can convert this into
Centimeter.
correct. So that will be 100
100.
centimeter and this is 75 centimeter. Now the question is you have to put up the sign. So what will be the sign associated with U and what will be the sign associated with V? Because it's a convex lens, it's mentioned already. What is the sign of U and V? Positive or negative? Yes, Rachel. U value, should you take it positive, negative? And also tell me for the V value.
Ma'am, V is positive and U is
Hmm.
negative.
Correct. Okay, so U and V is given. We have to find focal length. I want you all to try this because we've already done this type of question. So the formula is 1 by F will be equal to 1 by V minus 1 by U. Use this formula, put the values because U and V is known. Get the value of focal length. So Rachel get me the value of focal length and Adit get me the value of magnification. And Michelle, you're going to tell me the nature of the image. Everyone can add that as the third question, nature of the image.
ma'am, the I got the magnification. I think
Yes, how much is it?
is it minus 1.33?
No. So how did you solve it?
Ma'am, M is equal to V by U, right?
Okay. Mm, yes.
So
This,
you have to do minus one. Oh, sorry, V is 75. Sorry.
hmm,
Ma'am,
yes.
ma'am, for the first one, F is equals to 18.75.
Okay. Positive or negative?
Positive.
Yes, it will be positive.
Ma'am, is the magnification minus 0.75?
Yes, that is right. All right. So what will be the nature if it is negative?
Real and
Negative
inverted.
means correct. It will be real and inverted. Okay, I'll take the next question. So we have a lens that forms. A lens forms the image of an object placed at a distance 15 centimeter from it at a distance 60 centimeter in front of it. You have to find the focal length, you have to find the magnification and the nature of the image. First of all, here the type of lens is not known to us, but yes, the value of u and v is given. Okay, so the situation is u is of course the object distance 15 centimeter in front of it, so it's minus 15, and v value is 60 centimeter in front of it, it's not behind, so v value will also be negative 60 centimeter. Okay, these things are not given in the text, in the context over here. Positive and negative you have to read and understand very well and then put up those information. So because the image and the object both are in front of the lens, both will be taken negative. Okay. So Michelle, you're going to get the answer for focal length. How much is the focal length? And Adit, try for magnification. And Rachel, you're going to tell me the nature of image.
Ma'am, is the magnification 4 plus 4?
Magnification positive 4. Yes, that is right. Okay, so tell me what is the nature of image? Nature. Nature of the image.
And it's
Positive 4.
virtual erect. It's virtual,
Correct. It's going to be
so it will be
virtual and
magnified.
erect and also magnified. Correct. Okay, they get the value of focal length, Michelle. Focal length.
Is it 1 by 20?
Okay, then flip it. 1 by f will be 1 by 20.
So focal length is 20.
Yes, focal length will be positive 20. So if it's a positive value, then it's a convex lens. Okay, that's just an extra, but we have not asked you the type of lens. Okay, now we can take the next question. Okay, maybe you will answer this. There is a concave lens that forms an image of an object kept at 20 centimeter 20 centimeter in front of it. It's a concave lens already given to you. At the distance 10 centimeter on the side of the object. Side of the object means on the same side of the object. Wherever object is kept on the same side, you're going to get the image. So what is the nature of the image? And you have to find the focal length of the lens. Okay. So Nidhi, you're going to tell me, you're going to find the focal length. And Adit, tell me the value of u and v from the question. What is u value and what is the v value?
One second, I have to join back because like my screen is like black.
Okay.
Oh wait, now I can see it. Okay. Um, I have to say what is V and U, right?
Yes, what is u and what is the value of v?
U will be minus 20
Yes, correct.
and V will be on the side of the object. So will V be minus 10?
Correct. It will be minus 10. Okay, u and v is known. Nidhi, get the value of focal length, and Rachel, tell me the nature of the image.
Length will be minus 20.
The focal length is minus 20, right? Okay, yes. What is the nature of the image? There are two ways you can try that. First is use the formula m and write v upon u, where v value is minus 10, u value is minus 20, minus minus gets cancelled. So it's 1 by 2, which is 0.5. Okay, so m value has come out as positive 0.5 meter, sorry, not meter, 0.5. So what is the nature? Positive tells it is a virtual image and virtual erect image. And zero point 0.5, what you
It
get to know
is
from that?
diminished.
Correct, it's a diminished image. Okay, so this way you can predict the nature. Okay, so everyone write that down, the nature part, and then go to the next question. We have a question here. At what position a candle of length, now this time the length of the candle is given, that's an extra information. Sometimes that's also termed as size of the object or height of the object, okay, or length. Okay, so far whatever questions we were doing, we were only concerned with where the object was kept, that is the position of it. But object and distance, oh sorry, object and image, they do have certain height. Okay, like the height of, let's say, a candle is placed. Okay, so the height of this candle, let's say if it is 3 centimeter, and I'm just saying we have an image of that candle, which might be double of it. So even height can be included into your questions. That also gives you a lot of idea about the magnification. Okay, height always leads to magnification information. So let's take this question. At what position of a candle of length 3 centimeter be placed in front of the convex lens so that its image of length 6 centimeter be obtained on a screen placed at a distance 30 centimeter behind the lens? So the question related to it is also supposed to find what is the focal length of the lens in part A. Okay, so let us see all the information given. We just know that the candle has a height or length of 3 centimeter, and they want that the image is of 6 centimeter. Image of that candle is 6 centimeter, and it is obtained on a screen placed at a distance 30 centimeter behind the lens, and the lens is convex lens. So let's say I have a convex lens, and behind the convex lens, exactly at this position, which is 30 centimeter, exactly at 30 centimeter, the image will be obtained. These information we have, and we have to solve all the information accordingly. So we need to first find the u value, because they've asked us where should you keep that candle. So that is the value of u. So v is known to us. Tell me, v should be taken positive or negative because it is behind the lens. It's 30 centimeter. Should you take it positive or negative? Yes, you can tell me. Here you have your
I'm positive.
lens. Correct. Anytime you have things on the right side of the lens, you will always take that as positive. Okay, so it will be taken positive 30 centimeter. U is something we don't know, but we can keep it as it is. F also we don't know. Okay, so of course, when you don't know U, you don't know F, then only one information is there. So by directly using the lens formula will not work. So let's take some other value or the extra thing given to us. The height of the object. I'm just writing HO. What is HO? Height of the object. That's taken as 3 centimeter. And height of the image. Height of the image, it is taken as 6 centimeter. Now, height also can directly tell you the magnification value. Okay, so M value you can write Hi upon Ho. This is also one of the formula of magnification. One formula we have already done, V upon U. That is when you have been given the object distance and image distance. You can find magnification from that. And second way to find magnification is by the height of the object and the image. So image height will be always in the numerator and object height will be in the denominator. That means it is 6 by 3. 6 by 3 is positive 2. So M value you're going to get as positive 2. Okay, now you got this value. We're going to use it to find the value of U. So here there was directly no need of using the lens formula, but yes, the B part of the question, they have asked us to find the focal length. There you will have to use it. Okay, so write all these information. So what we get to know is magnification can be written as Hi upon Ho, and magnification can also have the formula V upon U. Okay, that means V upon U and Hi upon Ho, they are both equal to each other. So we're going to use this information. Hi upon Ho will be equal to V upon U. This is a very important part that we're going to use. So Hi upon Ho was, we got that as 2. V is given as 30 and U is something we need to find out. Okay, so U value will come out as 30 divided by 2, which is 15. Okay, so write that down. So once you get the U value, U is known to you. F is something you want to find out. V is already given. And here, from magnification U value, you have got it as positive. But then you know U value is always to be taken as negative 15 centimeter. Okay, that work you will have to do when you put up in the lens formula. Okay, so everyone can try that and tell me what value you're getting for the focal length. Also tell me, is it positive or negative? Yes, once you're done, then tell me. Yes, what's the value of focal length?
Positive 10.
Hmm, correct. It is positive 10. Okay. Now let's take one last question for today. Yes, everyone got the same answer. Or is there anyone who's getting a different answer? You can ask me right away. So there is this question. So here it's given a concave lens forms an erect image of one-third the size of the object, which is placed at a distance 30 centimeter in front of the lens. So you're supposed to find what is the position of the image and the focal length. Okay. Yes. Michelle, tell me what information is given to us. What
Mm,
information do we have?
the object distance,
Okay. How much is it?
um, negative 30.
Yes, it's going to be negative 30 centimeter. Okay. Now F is not known to us, V is not known to us. So I've already told you whenever only one information you have and rest of the two is not available, then 100% they will give you something related to magnification. That's for sure. Okay. So how will you read out and interpret the magnification part? It's an erect image. Erect means it's a virtual image. That means magnification value will be positive. Okay, and it's given one third the size of the object, so it's going to be 1 by 3. You can write it in this way, that's also fine. You want to get it in decimal, that is also fine, but I would suggest you can keep it in this way because later you see it's something related to 30 and there are chances that you will get it more easy to solve when you use it as 1 by 3. So this is the magnification value. Okay, I'm coming to the other screen. So magnification, we got that as positive 1 by 3. Now we know the formula for magnification is V upon U. Magnification is positive 1 by 3. V, we have no idea what it is. U, at least we know it is negative 30. So Adit, quickly tell me what is the value of V from this?
It'll
One,
be minus.
correct. It's going to be minus 10 centimeter. Okay. Now, Rachel, tell me when the value of V has become negative 10, what does that tells you? Is the image formed on the left side, that is in front of the concave lens or behind the concave lens? Is it to the left side or to the right side when the V value is negative?
It's behind the concave lens.
No, behind means it's on the right side.
Okay, then it is
So it
in
will be in the front.
left.
In front means on the left side. Okay. So by default, we have our lens, be it concave or convex. Object is always kept on the left side. So when I say in front of the lens means they're talking about left side and behind means it will go on the right side of the lens. Okay. So when the V value has been taken as negative 10, that means the image and object, they're both on the left side, that is in front of the lens. Okay. So we got the value of V. We have the value of U. Maybe quickly calculate the value of F and tell me.
It'll be minus 15 centimeters.
Minus 15 centimeter. Correct. So it should come as minus 15. Why? Because focal length of concave lens, they are always negative. Okay. So these are all the max questions I've picked up. Oh, let me see, we can do one more or try as homework. I'll be giving a worksheet today. which is based on these kind of numericals. Practice them. So majorly this chapter is almost over, and then we can take the next chapter. But we do have a last section where we have to discuss the magnifying glass and all that part. Little portion is left, and then coming week we can start off with the next new chapter. Okay, so tomorrow we'll continue with the mole chapter, and we're going to take the Avogadro's numericals. Once this is done, see, Gay-Lussac's is totally completed. Avogadro will be, we have already started, but we'll be taking it more on this part. And then comes the B part where we discuss the other gas laws and include into the numericals. So by afternoon, I will be sending you a worksheet for physics, which you can practice, and you can send it by Wednesday or Thursday.
Bye, mom. Have a great day.